So following on from the previous video, we've detected our point of inflection here. This is your x and this is your y here. We've detected our point of inflection. Now we need to check the concavity here. So it seems as if it's concaving down here, okay, and then here it seems as if it's concaving up, okay. So because our graph looks something like this. So here, point of inflection here. So it seems as if it's concaving up here, okay, concaving up, and then in this region here, it seems as if it's concaving down, okay. But we need to double check. So now let's look at f double prime within this region, and then f double prime within this region here, okay. So looking at f double prime. That's here, f double prime, and then for this region here, which is this region, here. Okay, so we are now considering this region here, where x is greater than 0 but less than e to the power minus 1. Okay. Oops, this one here. Sorry. Okay. So we are now considering this region here. So hang on. So f double prime in this region here. So to work out, to find out if this whole thing will be a positive or negative, visualize this inside your mind here. We are trying to establish if f double prime is positive. We are trying to establish if this whole thing here will be positive or negative within this region. So within this region here, visualize this in your mind here. Within this region here, that's this bit here. That's this bit here. Okay. So when x is within this region here, you can see that the natural log of x will be negative around here, but it will be a negative less than 1. Okay. So around this region here, the natural log of x will be less than negative 1. So hang on. So this is your f double prime here. So within that region, so visualize it as this. So hang on. So visualize it as this. This 2 here is this 2 here, okay, and then this 2 here is this 2 here, okay. But then the thing is, within this region here, this natural log would be less than 1, less than negative 1. So that's down here within that region. So what that means is that this bubble here will be less than negative 1. So you see, if this bubble here is less than negative 1, when you times 2, then overall this whole thing here will be negatively bigger than this thing here, if that makes sense. So when, for example, if within this region here, let's just say it's minus, this bubble here is minus 2, because within this bubble here, within this region here, this bubble here will be less than minus 1. So let's just put negative 2 into here. So negative 2 times 2 will be negative 4. You see, negative 4 and then you plus 2, it's still negative. So what I'm trying to say is that in this region here, this whole thing here will be a negative number. Okay, negative number. Well, x here, don't forget this x here. This here will be a positive because it's just a normal x. Remember, it's a normal x, not the natural log of x. It's the normal x. The normal x being this, it's always greater than well, it's always positive in this region here. The normal x. Okay. So what that means is that in this region here, this whole thing here will be negative. Okay, because you've got negative divided by a positive. Anyway, let's check it in. Let's now look at this region here. Let's now look at this region here when x is greater than e to the power minus 1. Okay. So hang on. So now let's consider when x is greater than e to the power minus 1. So f double prime was given to us by this. Okay. So now visualize this in your mind here. In this region here, don't forget this is e to the power minus 1. When x is greater than e to the power minus 1, that's all this region here. You see, when x well, if you think about it, in this region here, this thing here will be in this region here, this thing here will be greater than minus 1. So hang on. So what I'm trying to say is that this region here, which is this bubble here, it will be greater than minus 1. It will be greater than minus 1. So what that means is that this whole thing here will be a positive, because if you think about it, if this, even if you choose this point here, let's just say, well, remember this is going to be less than this region here is going to be greater than minus 1. So if you put, let's say, if you put negative half in here, let's just pretend, because remember in this region here it could be negative a half. So if you put negative a half in here, this whole thing here will be negative 1, and then you plus 2. So that would take you, that will make the whole thing here positive. My point here is that in this region here, this whole thing here will be positive. Okay, it will be positive. If you can't see it, you might have to pause the video and think it through. But overall, it will be a positive. Okay, so in this region here, sorry, hang on. So overall, f double prime here will be positive. Okay, so what that means is that in this region here, f double prime will be negative. In this region here, f double prime will be positive. So if f double prime is negative, then it means that in this region here, it must concave down. So this region here, it must concave down, which indeed it does. Okay, it's concaving down. And don't forget, our graph looks like this, something like this. And then in this region here, if f double prime is greater than 0, that will mean that f itself will concave up. So indeed it does concave up. See? So in this region it concaves down. In this region here it concaves up. Okay, so everything makes sense.